Now in the next couple of examples we're going to look at, they'll be slightly more involved, only in that x will not be isolated in each of the inequalities that we're given. So that will then need to be our first step. But after that then, the process will be identical to the two basic problems that we considered a minute ago. So our next problem is this. We want to solve the compound inequality x minus 1 greater than 2, or 3x plus 5 is less than 2x plus 6. So now we need to solve for x in each inequality. So for the first one, simply adding 1 to each member, we'll end up with x is greater than 3. And in the next one, if we subtract 2x from each side, we'll end up with x plus 5 is less than 6. Then subtracting 5 from each member, we end up then with x is less than 1. So we have the compound inequality x is greater than 3, or x is less than 1. I think you know then what we'll do next is to represent each of the inequalities using interval notation and replace the word or with the union symbol. So the x greater than 3 will translate into the interval 3 to infinity. We've replaced the or with the union symbol, and x less than 1 translates into the interval from negative infinity to 1. And each of those is graphed, you can see below there. And take a moment to reflect and decide what we would have to graph on the number line itself that would include all the points on both of those graphs. Now, since they don't overlap, I think you'll remember from earlier work that the best we can do is simply to replicate each of those graphs on the number line itself. So the union then is graphed in red on the number line. And so our final step then will be to express the solution, and we'll do it in two ways, interval notation and set builder notation. And in this case, there's really no more compact way to do it than simply to replicate what we have above. So in interval notation, we would have then 3 to infinity, union then with negative infinity to 1. And if we choose to put it in set builder notation, it would be the set of all x then, such that x is greater than 3 or x is less than 1.